Okay, besides doing a linear regression, besides doing a quadratic regression, there is another way for you to be able to take points and use those points to determine a standard form quadratic equation that would pass through all those points. I've taken these examples or these problems out of your textbook. It's on page 166. And I've worked out a problem, and then I will work one more example for you, and then you should be able to do the ones that are your assignment. So remember, each ordered pair is an X and a Y value. I have them kind of highlighted here to show you where I plugged them in. You've got an X and a Y, we've got an X and a Y, we've got an X and a Y. I've taken the standard form of a quadratic and I've written it ax squared plus bx plus c equals y. And now I'm simply going to take each one of those x and y values and I'm going to substitute it in the equation for x and y. So you can see right here I've highlighted the -3, which is an x value, in yellow. I've highlighted the x squared in yellow, and I'm showing you that I've plugged -3 in for the x. I've plugged -3 in for the x. I've plugged 2 here. It's still highlighted in yellow, but a slightly more mustard color. I've highlighted the y because I'm showing you that I've replaced this y with that 2. And then this little double arrow thing right here is just showing you that if you square -3, you get 9. And so now I have 9 times a. You get rid of this double sign plus a negative. That's just a -3b. I didn't have a value to plug in for c, and then my y is 2. So I now have an equation 9a minus 3b plus c equals 2. I'm going to repeat those efforts with the 2 other points as well. Plug in -1 for x, plug x squared, plug in -1 for x, plug in y for 0. -1 squared is +1. I didn't write it, but it's always understood to be there. I plugged in -1. I took care of my double signs. A positive and a negative make a negative. I didn't plug anything in for c. I plugged in 0 for y. And lastly, I plugged in 1 for x here, so that's 1x squared times a plus 1 times b. I put 1 in for x times b, plugged in the 6 for the y, and now I have 3 equations that involve a, b, and c. From the beginning of the school year, when we were solving systems, we learned how to write a matrix. You take, there's 3 matrices that you create whenever you have a system. You create the coefficient matrix, then you have the variable matrix, and then you have the constant matrix. So I took the coefficients off of each one of these variables, 9, -3, and 1, and I wrote down 9, -3, and 1. I took the coefficient in front of this a, which is 1. This b has a coefficient of -1. This c has a coefficient of 1. I wrote those down. Wrote down my variables a, b, c, and then my constant matrix, which is 2 and 0 and 6. So this is an equation. It's a matrix equation. Coefficient matrix times the variable matrix is equal to the constant matrix, and we solve that equation by multiplying by the inverse. There is no such thing as division. Normally we would say a times x. How do we undo times? We divide. Matrices don't have division, so we have to multiply by the inverse, and this is how we write multiply by the inverse. So we multiply both sides of the equation by the inverse, and we end up with our solution. So this is what I'm actually going to type into my matrix calculator. So as you can see here, I pulled up my matrix calculator, my Desmos matrix calculator. This part right here shows where I entered matrix A. Here's where I entered matrix B. And then on a new line, I multiplied the inverse of matrix A times b. That means that this right here is the answer. So the quadratic that will pass through those points is, remember, this 1 is the value of a. That means a equals 1, b equals 3, and c equals 2. So my equation is, whoops, I lost it. Where did it go? It is 1, 3, 2. 1, 3, 2. This is my A, this is my B, this is my C. So my equation is A, which is 1, x squared plus bx plus c is equal to y. And of course, you could rewrite that, put the y in the front like we normally do. I put the y in the back because that makes it easier to write the matrix, but we normally put y equals or f of x or whatever. But this would be the quadratic that would pass through those points. And just to verify, I typed the equation that we got from the result of our matrix, and I entered the 3 points, and you can see here's the parabola graphed for this one. If I turn it off, it goes off. And then here are the 3 points that they gave me, and you can see those 3 points are on the parabola. Okay, I'm gonna do number 18 really quickly to show you how quickly it can go if you're not having to do a lot of explaining. I'm going to take the 1, plug it in for x. 1 squared is 1a plus 1b, plugging in 1 for x. So b times 1 is 1b plus c equals 0. I plugged the 0 in for y. Now I'm going to do the same thing, plug in 2. 2 squared is 4a plus 2b plus c equals -7. And then I'm going to plug in the 5 for x. So 5 squared is 25a plus 5b plus c equals -16. My coefficient matrix is 1, 4, 25, 1, 2, 5, 1, 1, 1. I'm going to multiply that time. I'm going to take the inverse of that, multiply it times the constant matrix, which is 0, -7, -16. And when I enter that into a matrix calculator, I'm going to enter a new matrix. They call it C. If you want to go back and, rename it A, that's fine. It doesn't matter what you call it. But I do need to make sure it's a 3 by 3. And then I just use the tab button on my computer to tab through and put all my numbers there. 4, tab 2, tab 1, tab 25, tab 5, tab 1, tab, press enter, give myself a new matrix. This one needs to be a 3 by 1, and that is 0, tab, -7, tab, -16. Oh, I put decimals, not negatives. Negative. Okay, and now I'm going to type in C, raise it to the inverse, times, this is matrix D, and so there's my answer. A is 1, B is -10, A is 1, B is -10. C was, I think, 9. C was 9, so my answer is y equals ax squared plus bx plus c. And there's my equation.